Hey everyone! Today is finding unknown values in equivalent ratios. So let's get started. I'm going to give you two equivalent ratios and I'm going to show you what to do to figure out what they are. Let's review though. What is an equivalent ratio? Well, if you were to look at these two pictures and I were to ask you, hey, are these pictures equivalent? Are they proportionate? You look at them and you be like, absolutely not. One looks like a mini little girl Maya, and the other one looks like a short, fat troll or something, right? So this is an example of what I'm talking about when I say, no, they're not equivalent. They're not proportionate. What I am talking about when I say, hey, these two are equivalent, is this right here. We have two adorable girls. One picture is bigger than the other, but they're proportionate, aren't they? They're equivalent. I can't say they're equal, right? Because one is smaller than the other, but they both look the same. They are equivalent. And the way we found those equivalent ratios is that we times them by the same thing. So here we had 6. If we times that or divide that by 2, we get 3. Here we have 4. When I divide that by 2, I get 2. So that's how we keep things proportionate. If we decide that we want to times 1 by 3 and 1 by 7, we'd end up with a picture more like what we saw right here. We'd end up with something that was 18 inches tall, but 28 inches wide, which looks like this, right? The width ends up being longer than the height. So these two are not proportionate. So to make things proportionate, we have to do the same thing to both sides. Okay, so let me give you a real life situation where you do need to find unknown values with equivalent ratios. So I want to make cookies because y'all know I love cookies. My recipe calls for 3 cups of sugar for every 4 cups of flour when I'm baking cookies. Now, because I really, really, really like cookies, I don't just make one batch, like one recipe, right? I want to double or triple or even like more than that. And then maybe I could even share with you, right? So I want to increase my recipe, but I still want them to taste as good as my recipe that's a 3 to 4 ratio. So I look and I see that I have 20 cups of flour. How much sugar do I need? I've got 20 cups of flour and I want them to taste the same, so I need them to stay equivalent. Does that make sense? I want my recipe for my little cookies to taste the same as when I make a big batch of the exact same cookies. So how do we figure that out? Some of you might already be like, oh, I know what to do. I know exactly how many cups of sugar you need, which is awesome. The first thing you want to do is write the ratios. The first ratio was a 3 to 4 ratio, correct? And when I say match labels, here's what I mean by that. The 3 was for 3 cups of sugar. The 4 was for 4 cups of flour. So when I write the ratios, I need the sugar to be on top and the flour to be on bottom, just like I started out with. I know in my problem that I have 20 cups of flour. So I'm going to put the 20 down here with the 4 cups of flour that I have. So now the next thing I need to do is decide if the ratio is getting bigger or smaller. And I kind of already told you, right? I want a lot of cookies. So my ratio needs to be bigger. Okay, that's going to help me to find the unknown. Because if I'm getting bigger, I know I'm going to need to times both of those by the same number to get my recipe bigger, correct? So the last thing we're going to do is we're going to look for a relationship. Here's what I mean by that. A multiplicative relationship, or I'm looking for one number that's a multiple of another number. For example, with our flour and sugar, if I look and I have 4 and 20, there is a relationship here, isn't there? I'm going from 4 cups of flour to 20 cups of flour. So I'm actually making it 5 times bigger. I'm making not just one batch of cookies, I'm making 5 batches of cookies. So I'm getting bigger. See how my ratio is getting way bigger? So if I'm going 5 times the amount on my flour, that means I need to do the exact same thing to my sugar. I need to get 5 times bigger with my sugar, then they'll be equivalent, then they'll taste the same. So 3 times 5 is 15. I know that I need 15 cups of sugar to make my cookies taste the same as when it was just the 3 to 4 relationship. Okay, let's practice that a little bit more. So, in warm weather, the Anderson family likes to spend time in the family's boat. The boat uses 2 gallons of gas to travel 12 miles on the lake. How much gas would the boat use to travel 48 miles? All right, do you see this is a ratio right here? We are comparing gallons to miles. So I'm going to make my first ratio be 2 to 12. And honestly, because it's ratios, if you wanted to do 12 to 2 instead, that is totally and completely fine. What is important though is that I make sure I have my gallons on top, because this is 2 gallons, and my miles on bottom, because this is 12 miles. Okay, now the question was, how much gas would the boat use to travel 48 miles? So instead of going 12 miles, I'm going 48 miles. So I'm going to put 48 on the same line as the 12 because those are both my miles. And the question is how much gas. So I don't know how much gas, how many gallons of gas I'm going to use. That's the unknown that I'm going to find out. So I have written the ratios. I can see that instead of going 12 miles, I want to go 48 miles. So I'm getting bigger, aren't I? That means now that I know I'm going to end up multiplying because my ratio is getting bigger. What I want to find now is a relationship from 12 to 48. Is there a relationship there? Yeah. 12 times 4 is 48. I want to go 4 times the distance. So I'm going to need 4 times the gas. 2 times 4 is 8. I'm going to need 8 gallons of gas to go 48 miles. Kind of cool? Okay, let's try another one. Let's try some without the word problems just to see if we can find that relationship. So these are already labeled for us. They're already in the right spot. We just now are looking for that relationship. If I look, is there a relationship between 10 and 5? Yeah, there is, right? Now, am I timesing by 2 or dividing by 2? Here is how I figured that out. I have 4 to 5. That's the known. The unknown is something to 10, which means I'm getting bigger. I'm going from 5 to 10. I need to get bigger, meaning I need to times by 2. So the answer is that 8 to 10 is equivalent to 4 to 5. Okay, on this next one, we have 18 to 24 is equivalent to 6 to something. The unknown is over here in the smaller ratio. We went from an 18 to 24 down to a 6 to something, and 6 is smaller than 18. So on this one, I know I'm going to need to divide when I figure out what that relationship is. 18 to 6, 18 divided by 3. 18 divided by 3 is 6. So to keep that proportionate, I'm going to also divide my bottom number by 3, and I'm going to get 8. Interesting, both of those have an answer of 8. One I got from timesing, my ratios were getting bigger. The second one, my ratio was getting smaller, so I needed to divide and get it smaller. This question, I'm going to put myself in the picture frame right here. Cute. The width of Jay's original photo is 5 inches. So the width is the shorter side, 5 inches. The length of the original photo is 7 inches. He prints a larger version that has an equivalent ratio of width to length. The width of the larger version is 20 inches. What is the length? So I'm going to start with that first ratio it gave me, the 5 to 7 inch ratio. And the 5 stood for the width, right? The width is 5 inches. So I want to make sure my width is on top. And the length is 7 inches. So then when I go to write my equivalent ratio, which it says the width of the larger version is 20 inches, That was the width, so I'm going to keep it up there with the 5. What is the length? Well, now that we've got everything labeled, we're getting bigger. We're going from a 5-inch width to a 20-inch width. So we're going to be timesing, aren't we? Times by what? What's the relationship there? Well, times by 4, which means I'm going to times the bottom by 4 as well. And that means that the length is going to have to be 28 inches in order for the photo to be proportionate, right? In order to have the picture look like the 5-by-7-inch picture and not like the short troll picture of Maya from earlier, correct? It takes 20 minutes for Sue to make 4 laps around the go-kart. How long did it take Sue to go 2 laps? Well, it took 20 minutes to go 4 laps, so 20 to 2 will be my first ratio. And 20 minutes and 4 laps. So how long did it take Sue to go 2 laps? Well, the 2 laps needs to go with the laps, right? So I'm going to put it down there. And do we have a relationship? Yeah, we do. She went from 4 laps down to 2 laps. We're getting smaller. So we're going to be dividing. 4 divided by 2 is 2. 20 divided by 2 is 10. So it only took her 10 minutes, right? All right, you've got that down. I want to show you one more trick with this. You want to say hi since you're distracting? Can you figure this out?
It doesn't take 20 minutes to go around a go-kart track.
He says it doesn't take 20 minutes to go around a go. 4 laps around the go-kart. Cart?
5 minutes per lap?
Ooh, he just said a unit rate. He figured out that that's 5 minutes a lap. Yeah, that's kind of extreme, isn't it? Must be a really big lap. Thanks for ruining my lesson. All right. 20 minutes for 4 and 2. Did any of you notice? Have any of you thought that, hey, would this work if I found the relationship up and down instead of from the known to the unknown? Let's see. 4 times 5 is 20. So what if I did the exact same thing over here? I took my smaller number on the bottom, times it by 5. Does that still give you 10 minutes? Yeah, it does. So actually these relationships that I've been teaching you not only go from known ratio to unknown part, but from the top to the bottom or from one label to the other label. So sometimes if you can't find a relationship from known to unknown, look up and down and see if there's a relationship there. Okay, let's see if you can try it. John bought 5 raffles for $12. How many tickets could John buy for $48? Well, I kind of already taught you that we put money on top. So I'm going to put my money on top there for 5. And because 48 is also dollars, that's going to go on top. I notice that I'm going from $12 to $48. I'm getting bigger. I'm going to times by 4, which means I'm going to get 4 times the amount of tickets. I'm going to get 20 tickets. How'd you do on that one? Pretty good? Okay, let's do one more. Let's kind of do a test prep one. A speedboat can travel 24 miles on 3 gallons of gas. How many miles could the boat travel on 12 gallons of gas? All right, let's do the first ratio, 24 miles on 3 gallons. And now where am I going to put the 12? Do I put it on top or do I put it on bottom? Where'd you end up putting it? Hopefully you put it down here with the 3 because both the 3 gallons and the 12 gallons are gallons and we keep matching the labels. That's how we keep things equivalent, right? And I notice that there's a times by 4 relationship here. So if I times by 4, 24 times 4 is, getting my face out of the way, 96. Does that make sense? Yeah, because I went further, or I had 4 times the gas, so I can go 4 times the distance, can I? Okay. Did any of you try it the up and down way, where you can find a relationship up and down instead of side to side? Because there is a relationship there as well. It's times by 8. We're getting 8 times bigger from bottom to top. So that means this top is also going to be 8 times bigger than the bottom. 12 times 8 is 96. So we still got 96. Either way, it would have worked. How cool is that? All right, friends, have fun practicing finding unknowns and equivalent ratios.